Hey, welcome to 10.4. This is ellipses at the origin. Now, I want to tell you before we get started, an ellipse is a fancy name for an oval. So basically today we're going to be graphing ovals, and it is similar to how we graph a circle, but there are some differences. In fact, I mean, there isn't a radius because there's no constant distance from the center. Here's a few vocabulary words to get you started. So an ellipse officially is a set of all points so that the sum of the distances between x and y and two distinct fixed points is constant. So we're coming back to another type of graph that is going to have focus points. And again, we're going to graph them in Algebra 2, but we're not really going to do more with them. So here in Algebra 2, I'm just going to teach you how to graph, and then when you get into future math courses, you'll learn more as to why we can graph it and other properties they have. For our ellipse, there's a few key things that we have here, and while I talk about them, I will draw you a picture. I can either have my equation as x squared plus x squared over a squared plus y squared over b squared equals 1, or I can have it the other way around with the a and the b. And the a and the b are significant because they help us determine how far out to go with my ellipse, and I'll say more in just a second. But for this section, all of our center points are going to be at 0, 0. And then I've got a few different things going on here. So you know, when you look at an oval, let's say I had an oval right here. Part of the oval is longer than the other part. This part that's longer, these 2 points are always called the vertices. So I have a vertex here and a vertex here. And by the way, the vertex also always matches with an a value. So we always use the value of a to represent my vertex. And if you look at what I put up here, the official definition for a vertex is the intersection points of the ellipse and a line through the foci. And the foci is a plural for the word focus. Basically they mean I could draw a line right through here, and my focus points are going to be on the same line as the vertex, and that is also called the major axis. Now, the other points that I have here, those are called the co-vertices, and it's actually always the case that the long side has a vertex for either endpoint, and the short side has the co-vertex for either endpoint. And for co-vertex, we always use a b value. And in this situation, it's up on the y-axis, so 0, b, or 0, negative b. And then the reason I have two different things here is that this is now going the other way. So now it's just that my long way is vertical, and that is called the major axis. The long side is going vertical, and the minor axis, or the short side, is going horizontal. And again, a key point is that the long side, those are always the vertex points. And the a value always goes with the vertex. So here, my vertex is actually at 0, a because it's a point on the y-axis. And we're going to talk more about how to find those points in a little bit, so you don't have to necessarily have this memorized. So here, these two are the co-vertices. So my co-vertex and my co-vertex. And that is at b, 0 and negative b, 0. So we always use the variable a for the vertex and the variable b for the co-vertex. And then the other thing I want to point out to you really quick is that if the a is with x, and that's going to be the bigger number as well, if that's with x, it means that along the x-axis is where it's longer. And if a, which is always a bigger number, is with y, it means the y along the y-axis is the longer side, basically. And I'm going to say more about that when we get to graphing. There is just a few more things I need to show you, and that is how to find the focus points. And so I have the focus points here and here, and they are always on the same axis as the vertices. So if my vertices are on the x-axis, so are the focus points, and if my vertices are on the y-axis, so are my focus points. And we have a third variable we use for the focus points, and it is a c value. And so I know this is getting a little crowded here, but the focus points are at c0, negative c0 for that graph, and here at 0, c, and 0, negative c. So it's always a C for the focus. Those don't change. Those are always C. And the way we find our focus points is by using this equation, c squared equals a squared minus b squared. It is related to the Pythagorean theorem in some way, but we don't have time here for me to show you exactly how it's derived. But just trust me, if I take the c value and square it, it's equal to the a value squared minus the b value squared. And then we have something called the eccentricity, and that tells us how oval our ellipse is. So it's a measure of the ovalness. And you find the measure of the ovalness by doing c divided by a. And that one's easy, just c divided by a. Okay, so let's do a few examples, and then I'll give you I've already said it, but there's a few key things we'll write down kind of as we go along. So first key thing, the a value always goes with the vertices, and the a value is whichever number is higher. So if I look at example 1, this number here would give me the a value for A, and this number here would give me the a value for part B here. Now the other thing I want to point out that you may have noticed I didn't specifically mention, but those numbers underneath the x and y, they're a squared and b squared. So 64 here is actually a squared. So if a squared is 64, that means a is 8. And the other number is always b. So here the square root of 9 is 3. And we'll kind of do both problems at once as we're going along here. And so this time, again, the larger number is just what the a value is. And the square root of 36 is 6. The square root of 25 is 5. So for part B, b is 5 and a is 6. Okay, now here's the deal. If my a value is with x, and remember, a is with the vertices, so maybe we should write that under the important section here. The a value always goes with vertices. If a is with an x, the vertices have an x value. And by the way, we were also asked, we'll just find the center too. The center is going to be 0, 0 for all of these. And I didn't really say much about the center, but the middle point in the middle here is the center of the ellipse. Okay. So my center's at 0, 0. My vertice points, again, it's with the x, so it goes with x. So my vertices are going to be at 8, 0 and negative 8, 0. And the co-vertices, which I'm going to explain or abbreviate as CV, are always the b value. So I'm going to say under important, the b value always goes with the co-vertices. So, and also b is with y, so I put it in the y spot. So my co-vertices are at 0, 3 and 0, negative 3. And let's start a little sketch here so you can see what's happening. It didn't actually say to graph it, but I think it'll help you visualize what's going on. So my vertices are at 8, 0 and negative 8, 0, and my co-vertices are at 0, 3 and 0, negative 3. You can also kind of just graph it to see if, to kind of check your work. And one thing I want to mention is that you can always also check yourself, because if the bigger number is with x squared, the x-axis should be longer, and that's called the major axis. So here the major axis is the longer one, x is the bigger number, check, we got it. Okay, and last but not least, we need to find the focus point and the eccentricity. So now, to find the focus point, we're just going to use this little formula that I just gave you, or it's written on your notes sheet actually. So c squared equals a squared, which is 8 squared. And by the way, these numbers here and here are always just a squared and b squared already. So there's no sense in me saying 8 squared and then having to do it in a step later. I can just say, okay, that's 64. And b squared, 3 squared, or just 9. So c squared equals 55. And we do want to leave it in exact format, which means for some of these, you are going to have to simplify a square root. And remember how I said the focus points always go on the same axis as the vertex points? So here my focus point, if my vertex has a 8 for the x value, then the focus is also an x value then. And last but not least, I need to do the eccentricity. And eccentricity is just c over a. So just square roots of 55 over 8 for this situation. Okay, we're going to do B. So here's what's happening. First of all, I've already figured out my A and my V value, and the center is at 0, 0. Okay, my vertex then, this time the A value is with Y, so my vertex goes in the Y spot. So 0, 6 and 0, negative 6 for my vertex. And then remember, B always goes with the covertices, and the B is with the X value, so put it in the X value spot. That's how I kind of remember that. To find my focus point, I need to use my formula. So c squared equals a squared minus b squared. A squared is 36, b squared is 25. And I kind of remember this as it's always the biggest number, subtract the smallest number. Okay, c is the square roots of 11. And then I want to just point out again that the vertex and the focus always are on the same axis. So if my vertex, for example B, was in the Y area, my focus has to be in the Y area here. And then last but not least, my eccentricity, which is c over a, so square roots of 11 over 6. C is square roots of 11, a is 6. Please feel free to pause and write that down and rewatch that part if you need to. We're going to move on to writing equations. So what we just did is I was given an equation and we tried to find all this information. With the next example, I'm giving you a bunch of information and we have to create the equation. For example 2a, I know what the vertices and the covertices are, and I want you to think back to my special important note I gave you. So if the vertices are always where a goes, so a is 5, and then also it's a x value. It's a x value. So I'm going to put it with x, and under here, so let's just backtrack a second. This was the equation. A squared is 5 squared, so I'll put 25 there. And the covertices are at 3, and that's b, and that's a y value, so it goes with y. 3 squared is 9. That's my equation. We're also supposed to find the missing parts, and in this situation, my missing parts are the foci, or the focus points. So I'm going to find c. And again, the shortcut I gave you was it's really just the big number subtract the small number. So here 25 subtract 9, which ends up being 16. Okay, c is 4. And then I just have to think back because remember, focus points, same plane as the vertex points. So my focus points are going to be x values. So 4, 0, and negative 4, 0 then for my missing points there. And you can always think about the equation this way. So this is what it is for our graph at 0, 0. I just have to figure out what a and b are. And by the way, I know for this example, I know what the vertices are. They're at 13. So the a is 13, and then check it out. Right now, that is a y value. So this time it goes with underneath the y. And 13 squared is 169. So there it is. Now be careful, because I don't know right now, I don't know what b is. I was actually given the vertices, which gives me a, and I was given the foci, which gives me c. I don't know what b is, but we actually can use that same equation that we used before in order to find b. So this time I know that I have 5 squared, and I know what a is too, actually. A is 13. And you know what? I just broke my other shortcut I just told you a second ago. If we already know that that's going to be 25 and that's going to be 169, you can write it down right away. You don't have to do the extra step in the middle. Okay, let's solve for b. So, subtract off 169. I end up with negative 144 equals negative b squared. Divide by negative 1. Okay, you know what? b is 12. And also, b squared is 144, which is what I needed for that anyways. So there I am. And then, remember, B is my co-vertex spot. And B is with the x right now, so I'm going to put that 12 in the x spot. And there it is. Okay, why don't you pause the video and try C, and then when you unpause, I'll have the answer showing. Alright, two things we should check right now. First of all, I was given the covertices, so did you say 4 was a B value? You're going to want to check that. And then the foci gave us a C value, so what I did is I went through and I found A. And A, because I knew the covertices, like that is in the x position, so I put 4 squared under x. So I knew that this other guy had to go with y, and so when I found my vertices, I put it in the y position. 5 is in the y position, and there's my equation. Okay, now we're going to go the other way, and this time I'm given the equation again, and I'm going to find all this stuff kind of like what we just did for example 1 actually. So some of this stuff I'm going to go a little faster through. Make sure that you pause if needed and rewatch anything if needed. So first of all, I want to figure out all this information it asked for. My graphs have a center at 0, 0 for this section, and then I want to find all this other stuff. Okay, here's what I want to remember. A is always the bigger number. Square root of 64 is 8. Square root of 9 is 3. Then, my vertex goes with the bigger number. And by the way, the bigger number is matching with x squared right now, so I'm going to put that in the x position for my vertex. The b value is going with the y this time, and that's the smaller value, so my y value is 3 and negative 3 for my covertices. And I'm going to pause and graph a little bit here. So I've got center at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Vertex at 0, 8. Oh wait, sorry, 8, 0 I meant to say. 2, 3, 4, 5, 6, 7, 8. There's my other vertex at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then my covertices at 0, 3 and 0, negative 3. I'm almost done. I just need to find and graph my focus points. Just do the best you can to draw an ellipse. It's okay if it doesn't look really good. Alright, let's find C so I know where my focus points are. Alright, using my same formula I've used a bunch of times already, let's go for it. A squared is 64. B squared is 9. And when I am making my focus points, I want to say square roots of 55 because I want to give an exact answer. And remember, focus points always match with the vertex. So if the vertex was an x value, I put this as an x value. The thing is though, I don't know how to graph square root of 55. Like I don't know where that is. So I will type that into my calculator to figure it out as a decimal, so that's easier to graph. And it's at 7.4, which is really close to the vertex, so I'm going to do my best I can to kind of draw that in there. And last but not least, the eccentricity, that was the C over A. So C this time is square roots of 55 and A is 8. There I go. They're just going to try to throw you off sometimes by having something that's not in standard form. So if I look at example B, the thing is, I have to have this number right here as 1. That must be 1. So I need to write this in standard form by dividing off that number. And it seems crazy, maybe, but it's 784 because I need to make it so that this is a 1 right there. That's what my ellipse formula is. That has to always be a 1 for an ellipse formula. And these were actually conveniently made so that they would work out kind of nicely. So actually 49 divided by 784 ends up being 1 over 16. And 16 over 784 ends up being 1 over 49. So it reduces down to that. Now I'm going to do the same process I did before. And by the way, remember, the bigger number always is the a value. So this time a is going with the y. And so when I make my vertices, it is a y value. So again, a always goes with the bigger number, and it's going with y, so it's a y value. B is 4 right now, and that goes with my covertices. And because that was an x value, b is an x value, so 4 and negative 4. So I got my vertices at 0, 7, 2, 3, 4, 5, 6, 7, 1, 2, 3, 2, 3, 4, 5, 6, 7, and my covertices are at 4 and negative 4. I'm not done yet because I have to find my focus point. So here I go. C squared equals a squared minus b squared. 49 minus 16. Okay, so c is the square root of 33. And again, remember that your point matches with what your vertex was. So the vertex was in a y value spot, so I'm going to put it in the y value spot. So 0 square root of 33 and 0 negative square root of 33. And then the eccentricity is c over a, which is square roots of 33 over 7. I'm not quite done, actually. I still need to graph the focus points. So just a second. See how square roots of 33 again? That's really hard to graph. So I'm going to convert it to 5.7. And that, remember, the focus point always goes on the same axes as the vertex points were. So there's approximately 5.7, 2, 3, 4, 5, and there's approximately 5.7 in the negative direction. And then I'm done. You can see I've got 2 more examples here. If you have time, go ahead and pause the video and try those. And when you unpause, I'll have the answers showing. Alright, here's the answers for C and D. I'll scroll down a little bit to show you the graphs. Go ahead and pause if you need to get that all down. Check your work. Did you simplify this correctly? That would be my one question on that one. You do want to have it in simplified square root form. Here's the graphs. Again, pause if you need to, and thanks for listening. We'll talk to you again soon.